Hello everybody, you are welcome to today's lesson. We are going to treat past questions in today's lesson and we are going to do as many as we can. We are treating 2021 past questions. As you all know that this is 2026, if there are questions they are likely to repeat, it's going to be likely from 3, 4, 5 years back. So let's treat 2021 NECO Mathematics past question. Let's go together. 25. We have to express this figure, this number in standard form. A number in standard form is written in this form. Okay? A number in standard form is written in this form. The A stands for the first digit of the number, the first non-zero digit. You put your point here after the first non-zero digit. Then any number in standard form will be multiplied by 10, then raised by a particular integer. An integer could be a negative number, could be 0, and could be a positive number. So the power could range from negative to 0 to positive. That's an integer. Any number that could be a negative that can be 0, and that could be a positive number. So our A is the first non-zero digit. So our A is 1. So we express this number in standard form. We move the point from where it is now, 1, 2, 3, to the first non-zero digit, which is 1. This is 1. So we write this A now is our 1. When I say 0.025 multiply by 10, this 10. The power now, let's check that power. How many times do we move the point from here to here? We move it 1, 2, 3. We move it 3 times. 3 times. Because the number is a number less than 1. A number that begins with 0 is less than 1. So our power will be negative. And that is option C. Option C is the correct option. Let's move to number 2. The question says we should find the positive difference between the nearest million and the nearest billion. Let's find the nearest billion first. Nearest billion will give us 90, right? 1, 2, 3, that is 1,000. 1, 2, 3, that is million. 1, 2, 3, that is billion. Then we have our 3 here. We have our 3. But before we write this 3, so nearest billion is this place. Okay, so our bus stop is actually this. So a number in billion is written in this form, this figure plus 9 zeros. Any number in billion, we have 10 digits altogether. From the first billion, are going to be the number plus 90 will give you a billion number. So this is going to be 3 billion right now. This number plus 90, that will be 3 billion. But because this particular digit is a senior number, what do I mean by senior number? From 1 to 4, we call this digit, we call it junior number. Junior number, right? Junior, let's say junior number. From 5 to 9, we call it senior number. So when you want to round up now, to round up to nearest billion, just before this billion, 3 billion, the number next to it is 8. And 8 is among the senior digits, right? Let me not call it a number, let me call it digit. This is digit, this is a digit. From digits 5 to 9, we call it senior. From 1 to 4, we call it junior. So just before the billion, the number next to it, the digit next to it is a senior digit. Therefore, we We call this one 0, right? So when you call it 0, then we add 1 to this place. So this will give us nearest billion. Nearest million was, we are stopping at 60. So 1, 2, 3, 4, 5, 6. This is the nearest million. Nearest million. So this one will be 8. Let's write it very well. 0, 0, 0, 0, 0, 0. Then we have 4. We have 7, 4, 8. So this is our 60. This is thousand. This is million, right? So we have number of this million. Number of this 847 million. Now look at this place. Before we get to our million, the number here is a senior digit. Because it's a senior digit, we add 1 to our million. So nearest million now, the next digit to it is senior. We turn this one to 0, then we add 1 to this one, making 8. Assuming this place is 1 or 2 or 3 or 4. So we will not need to add anything to this place. We just leave it at 7. This will be our nearest million. But it's not 1, it's not 2, it's not 3, it's not 4. It is 9. So because it is 9, so this 9 is a senior digit, we turn it to 0 and add 1 to this. So this one will change from 7 to 8. Why this one remain 3? This one remain 4. Yes, this one is 4 because we rounded it up to nearest billion. Why this one is 3? Let's do subtraction. We want to remove 8 from 0 is not possible. This one will become 3. This one is now 9. This one is 9. This one is 10. So 10 minus 8, that's 2. Here will give us 5. Here will give us 1. 0 minus 3 minus 3, that's 0. So our final answer is 152 million, and we are correct. This question is and is taken from indices, and we are told to evaluate. To evaluate this, let's change this dividing line to division sign. Let's change division sign line to sign. So let's express it this way. This line is now changed to sign. So we have this. Then we have this. Now, what do we do? The first thing to do is to remove this negative. Following the law of indices, to remove the negative, this one, instead of 1 over 81, it becomes 81 over 1. But writing the 1 is not necessary. So we write 1 over 2. Then we can change this division to times. I'm solving as if I'm solving a theory exam. When you're solving a theory exam, you show your working. So I'm showing you my working now. So division will change to times. This 0 over 3 is the same as, let me leave it first. Let me leave the division first. This 3, to change it to a fraction, we write 3 over 1. We write this number as if it's a whole number. So any whole number you see is always over 1. If I write 2, it's 2 over 1. If I write 3, any number you see is always over 1. Now let's write this 3 as if it's a whole number. So 3 over 1. Then to change it to fraction properly, we now look at our decimal point. How many digits you are seeing from decimal to the right side? To the right of decimal, how many digits are you seeing? You are seeing only 1 digit. So that will be 1 0 will be given to join the 1. Why? Because to the right of decimal, you have only 1 digit. So let's put 1 0 digit. Assuming it is 3 digits, it will be 3 0. 2 digits will be 2 0. 4 digits after decimal to the right, then to be 4 zeros. So this one, the same way, 0.009 will become 9 over, how many digits to your right? 1, 2 to the right of decimal. So this one will become 100. Then we have this one. Now let's change this one to times. This one, fractional power in indices. Fractional power is roots according to the denominator. So the denominator is 2, then we have a square root. If it is 3, it will be cube root. If it is 4, it will be root 4. So it is 2, it will be square root. Then we have 81. All raised to power of 1, which is not necessary to put it. It's not necessary to put the 1. Let's leave it like this. So we say this one change it to times. This one become 10 over 3. Then let's apply this. Fractional power is root according to the denominator. This one will become 9 over 100. All raised to power of this 1, but it's not necessary to put it. So we find the square root of 81, which is 9. Then we have 10 over 3. We find the square root of this, which is 3 over 10. This one, we cancel this. This one, we cancel this. Our answer is 9. Is it there in the option? 9 is there. That is option B, 2021 NECO pass question. Let's move to the next one, which is number 4. Number 4 says simplify this. Another indices question. Number 4. To solve this one, the denominator is 3 this time around. This number, as I told you, write it in a fraction form. Write it as if it's a whole number, 27 over 1. This decimal point, right? To the right of decimal, how many digits? 1, 2, 3. So we put 3, 0. This is fractional power law. Now let's apply fractional power law. Fractional power is roots according to the denominator. Denominator is 3, then it will be root of 3, cube root. Then squared, bracket raised to power of this 1. But because it is 1, we don't need to write it. This one is going to be 9 over 100 because to the right of point 1, 2. So we'll put 2, 0. Fractional power is root according to the what? Denominator. So it's going to be square root here. Then we put our negative 3. If we want to remove the negative, then it will become 100 over 9. Let's do this one. Cube root of 27 is 3. Cube root of 1000 is 10. Then square root of this will give us 3 over 10. While cube root is also 10. Let's not forget it's raised to power of negative 3. Negative 3. So when we do that now, I'm going to have 3 over 10 times, you can change it. This one will give us 10 over 3. Then the minus is gone. Then you now have 3 here. Is that right? So this one will give us 3 over 10 times 1000. 10 raised to power 3 is 1000. Then 3 raised to power 3 is 27. So this 0 will remove this 0. This 3 will remove. 3 goes in 27 is 9. So we have 100 over 9. Let's check the option, what is there. Looking at our option, the option is not there. We change it to another form. This option is not in the choices provided, in the option provided. This answer is not there. So what do? Let's change it to another form. 100 is the same as 10 raised to power of 2. 9 is the same as 3 raised to power of 2. Then the two of them can be written in this way. All raised to power of 2. If we look at it, our option is not sit there. So what do? I can see negative power instead of positive power. I can see negative power. I can see negative power in the option. There is no positive power. So all I do is to introduce negative. And if I introduce negative, this one will go up, this one will come down. Instead of 10 over 3 to become 3 over 10, and in that case, there will be negative here. So if you are changing to negative, 3 comes up, 10 goes down, right? And if you are changing back to positive, 10 will go up, 3 will come down. That's how to introduce negative in the power of a fraction, or to remove negative. Just inverse the fraction. So this is the option, correct option, and that is option A. That is option A. That's the correct answer. Let's move to number 5. The question says a particular bank paid 50 kobo dividend per share. What will be the percentage yield for a customer who invested 5 naira per share? A particular bank paid 50 kobo per share. What will be the yield or dividend percentage yield for a customer who invested 5 naira per share? The first thing is to change this naira to kobo, so that it can be the same value with this, the same unit, kobo and naira. So how many kobo do you see in 1 naira? That is 100 kobo in 1 naira. So to change this one to kobo, just times 100, and that will be equal to 500 kobo, because in 1 naira we have 100 kobo. So to change this one, to convert this 5 naira to kobo, multiply by 100, this one will give us. So he invested 500 kobo, and on top of 500 kobo, each 500 kobo is getting 50 kobo on top of each of these. So what is the percentage yield? We don't know the percentage yield. So we can say let the percentage yield equals X percent. X percent, can write like this, X. Let the percentage yield equals X percent. Let the percentage yield. What is the percentage? We don't know it. So let the percentage yield equals X percent. So from the question given to us, X percent of this will yield this, because they have already given us the dividend, but they are not asking us for the dividend. They're asking for the percentage of the dividend. So they're asking us for the percentage of dividend based on the investment per share. Investment per share is 500. So what we do is to say X percent of this will give us this. That is the expression. X percent. What is the percentage yield? The percentage yield of this, we are told, is going to give us this. So we write X percent of 500 kobo will give us this one, because this is the dividend the man is giving, the customer is giving. So X percent of 500 kobo will give us 50 kobo. So in that case, anything percent is that in over 100. 20% is 20 over 100. So X percent is what? X over 100. 1000% is 1000 over 100. 5% is 5 over 100. So X percent means X over 100. Of means times 500 equals to 50. So X percent of the investment will be given, the man will now get 50 kobo per share. Now let's do the math. X times 500 will give us 500x. 100 times 1 will give us 100, equals to 50. 50 over 1. If you cross multiply, you have 500x equal to, this times this, give us 5,000. 1, 2, 3, 0. 1, 2, 3. So if you divide both sides by 500, you're going to have 500 over 5,000 over 500. Yes. This 2 0, we cancel this 2 0. 5 in 5 is 1. 5 in 5 is 1. 5 in this 0 is 0. So we have 10 over 1, which is the same as 10. So the percentage yield from what we have seen now is 10%. So our X percent, the percentage is what? 10%. And there is 10 in the option D. Let's move to the next one. 8. So we are told to solve this problem and make our answer to leave our answer in standard form. I want to solve this as if I'm solving a theory exam. In case you have a theory exam, in case in your theory you see something like this, you'll be able to solve it. But if it is objective, just like this one, you don't need to solve it. Just press calculator and multiply this and divide by this, then convert the number to standard form. So, but in case you want to do a theory exam, this is how to go about it. One way to go about it is to convert everything to a whole number. How many zeros we have here? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. One way is to multiply everything by 100,000, but that will be too big. So what we do is to change each of them to standard form. This one is already in form of standard form, 1.6. Like can write 10 raised to the power of 0. 10 raised to the power of 0 is 1. 1 times this will give us this. So this one is already in standard form. Then we have times there. This one in standard form will be 8.4. You move the point to the first non-zero digit. Then how many times do we move it? 1, 2, 3, 4. 4 times. Write 4. So because the number is not up to 1, it's a less than 1 number, then you introduce negative. So that is it. Raised to the power of negative 4. Then this one will give us, you move it from here 1, 2, 3. It will be 4.8 times 10 raised to the power of negative 3. Why? Because it is a number less than 1. Start with 0. The power 2 will be negative. We have 8.4 times 10 raised to the power of negative 4 can be expressed this way. 10 can be expressed this way. 10 raised to the power of 1, negative 1, times 10 raised to the power of what again? 10 raised to the power of 3. When you add these two, you get 4. When you add these two, you get 4. Because I want to use this one to cancel this one. So we now have 4.8 times 10 raised to the power of negative 3. So this one, we go in this one. Right? So what do we do right now? What do we do to remove this? From this point, let's change everything to a whole number. I multiply everything by 10. Multiply everything by 10 to change it to a whole number. So we have 16 times 84 over 48 times 10 raised to the power of negative 1 times 84 equals divided by 48. So we're going to have 28. We have 28 times 10 raised to the power of negative 1. It's not yet in standard form. There is no point here, so we introduce point. So 2 point, the point shift from here to this place. Shift from here to here. This point 0. So you move it 1 time, right? So we're going to have, so 10 raised to the power. How many times do we move it? You move it 1 time. Then also, so this one will be 1. Positive 1 this time around. Then times 10 raised to the power of negative 1. So we have 2.8. So times 10. If you add these two together, you're going to have 0. So 10 raised to the power 0. The total answer is going to be like this. 2.8 times 10 raised to the power of 0. And option C is our answer. 2.8 times 10 raised to the power of 0. Let's move to the next one. The cost of a motorbike is 110,000. If the value depreciates by 10% yearly, what will be its value at the beginning of the following year? Cost of motorbike. Bike will cost, from the question, bike costs this amount, 110,000, right? And depreciation rate, depreciation rate, it depreciates yearly. Depreciation is 10% every year. Every year there's a depreciation of 10% from this amount. So the next year, what will be the value of the bike? What will be its value at the beginning of the following year? That is the next year. Now, the depreciation of this is 100% as it is right now. Is 100%. But at the end of 1 year, it will not be 100% again. It will have depreciated by 10%. As it is equal to 100%. So after depreciation, after 1 year, we are going to have 100% minus 10%. So we are going to have 90% remaining. So after 1 year, the cost of the bike is this. Every year it depreciates by 10%. After 1 year, there will be a loss of 10% every year. So the next year, the value of the bike will be 90% of the cost of the bike. So 90% of this amount is what we are told to find, the cost after 1 year. So 90% is 90 over 100 times 110. So when we do the math now, this 20 will cancel this 20. So 9 times 1 is 9. 9 times 1 is 9. How many zeros do we have? 1, 2, 3. 1, 2, 3. So what will be its value at the beginning of the year? The value at the beginning of the year is going to be 99,000. So the value at the beginning of the year is going to be 99,000 because 10% is already gone out of the 110%. The value of the bike will be 99,000 after a year. So let's move to the next question. The next question is about set. We have two sets there, two subsets. Set A, total number in the set of A is 26. And the set of B, total number there is 19, equals to 19. Some numbers are common here. Out of these 26 and 19, 11 numbers are common. So we have n number of the common values. Out of these 26 and 19, the number of the common one, A intersect B. How many number exists here out of the 26 and also exists here out of the 19? We are told the numbers are 11 numbers. That is, let's say all numbers are from the first odd number is 1. We have 2. No, we have 2, 3, 5, 7, 9. These are odd number. Let's call this place our set A. Then set B, the first prime number will be 2. We have 11. So assuming these are sets, we have common numbers, right? So we write this one is common, this one is common, this one is common. So if this is A, this is our B. So A intersect B will be 3, will be equal to 3. So that is what is playing out here. So out of the set of A, we have about 26 numbers. Out of the set of B, we have 19 numbers. But out of these 19, 11 numbers are common. So they intersect. That's why we have 11 here as intersect. So we are told to find A union B, the number of A union B. That is what we are told to find. number of A union B. Now, how do we find this number? We simply write everything in A and B is what they mean by union. Union simply means every number here and every number here, meaning that the number in A plus the number in B. This is supposed to be the union of A and B, everything in A and everything in B. So it's supposed to be 26 plus 19, everything in A and everything in B. But there is an intercept. There are numbers that appear here and also appear here. So we remove the intercept minus number of the intercept. So what this one means is 26 plus 19 minus the intercept. This will give us our answer. So let's do the math. 26 plus 19 equals minus 11. So our answer is going to be 34. That is option B. So we move to the next question. So this is also an indices question, but this one is equation involving indices. How do I know it's indices? There's power there. How do I know it's equation? There is a equality sign. So this is equation involving indices or indices involving equation. Now, what do we do at this point? We collect like 10. Let this one come here. So we write 2y raised to the power of 1 over 4 equal to 5. This one becoming plus there. 5 minus 1. Here we have 4. Here we have 2y raised to the power of 1 over 4. If we divide both sides by 2, there's a factor here. 2 is common here. So let's do divide by 2. Divide both sides by 2. So we are going to have y raised to the power of 1 over 4 equals to 2. To remove this 1 over 4, we need to multiply the powers by 4. Let's multiply both powers by 4. So we have y here, 1 over 2, 1 over 4 multiplied by 4. Then we have 2 raised to the power of 4. So there's a 1 here that we cannot see before. Let's put a 1. Then multiply by 4. So this is what we are going to have right now. The 4 here, we cancel the 4 here. So we have y, then 1 times 4, that will give us 4. 2 raised to the power of 4. And 2 raised to the power of 4 is 16. So our y is going to be 16. That is the answer. So we move to the next one. The next one is also an indices question. So here we have equation involving indices. So what do we do at this point? We multiply both powers, double powers. And we have double powers, they multiply themselves. So we have 2, this one will give us 3x over 2. Then we have 1, can we reciprocate? Let's reciprocate this. Instead of 1 over this one, let's write 0.25 over 1. Then introduce a negative 1. So we reciprocate it. Instead of this one be 1 over this, let's write it as if it's a whole number and introduce negative. There's another law of indices there. So we have this one. Anytime you reciprocate a fraction, always introduce negative. So negative 1. Since there's no number here before, so we write negative. Not only negative, then we put 1. So what do we do here now? We can change this one to fraction, and it will give us 25 over 100, all raised to negative 1. Then this one will give us 2 raised to power 3x over 2. When you reduce this number to lowest term, you're going to have 1 over 4, right? So we have 3s over 2, 1 over 4 raised to power of this. Let's nullify the minus again. by writing 4. Instead of 1 over 4, we write 4 over 1. So we write 2, 3x over 2. We don't want the minus again. Let's write 4. 4 is to power, just 4. That will be ordinary 4. 4 is to power 1 is the same as 4. Let's just write 4. This 4 can be written as 2 raised to power 2. So we have 3x over 2. Then we have 2 raised to power of 2. These 2 will cancel these 2, right? So we will be left with 3x over 2. The power will equal themselves. The moment the base cancel themselves, the 2 powers will equal themselves. So we have 3x over 2 as the power of this place. Then we have 2 as the power of this place. At this point, we cross multiply. We have 3x equals to 4. Then x equals to 4 over 3. Let's check our option. The option is not there. So what is there is this one. So how many times will 3 go in 4? To go 1 time. So 1 whole number 1 over 3. Don't be tricked. They put this one there, 3 over 4. 3 over 4 is not the same as 4 over 3. So this is not there. This is not there. Instead, they put this to trick you. So you must change this to a mixed number. So this is the proper answer and not this one. So that is the end of number 10 question. I think at this point, you can stop in this video. So you are welcome to the end of the lesson. If this lesson is beneficial to you, please try to subscribe to my channel. Have a beautiful experience. Watch out for the next lesson. When you subscribe, please press the notification button so that any new video coming, you will be one of the people that will see it and enjoy it. Thank you and God bless you.